All right, stats. So last section in chapter 3, 3.9, using studies wisely. So again, this is going to get into the true scope of inference of our experiments slash observational studies, and then also ethics and how that plays a role in your sampling and surveys and experiments and observational studies and all that fun stuff. So this is a huge important slide. So the scope of inference, right? Scope of inference. And again, I got to emphasize that word inference because that's what we're going to do the later half of this class. So notice these 2 points. Number one, random selection, which means random sample, right? Random selection of individuals allows inference about the population. If you have a random sample from the population, you can make inferences about the population, right? So, for instance, if you want to be able to generalize something to the entire school population, don't just pick one class and like don't just pick my stats class and ask that group of kids. You have to pick, maybe you go block 1 and go in all the different classes and ask a bunch of different kids. Okay. So again, keep in mind who you're sampling from, and then number 2, random assignment. Random assignment lets you make inferences about cause and effect, okay? So again, random assignment lets you imply cause and effect. And the idea there is, remember, if you don't randomly assign your individuals to treatment groups, then you don't know if, say you put all the boys in one group and all the girls in the other group, then again, it could be a gender thing, not the treatment that you're giving. So again, random assignment is very important. So this scope of inference right here, this is super duper important for you to think about. So random selection. Can I infer about the population? And again, if there was random selection, inference about the population, inference about the population. If there wasn't random selection, no inference about the population, no inference about the population. Up here, random assign. Random assign means cause and effect. Yes. Cause and effect, yes. Cause and effect, yes. No random assignment, cause and effect, no. Cause and effect, no. Okay, so again, keep in mind this, and it's about random selection versus random assignment. And again, what you want is you want this box. You want to do both in your experiments and your studies, so then you can make inferences about the population and inference about cause and effect, which is the true goal of any experiment. Okay, so example 1, feeling sleepy. The headline of a recent article declared, study, teens getting less sleep, social media could be a reason. Duh, that's a no-brainer. Put your cell phones away. Using random samples of teens from 1991 and 2012, the study found that teens are getting less sleep than they did 20 years earlier. For example, just over half of 15-year-olds report at least 7 hours of sleep in 1991, but only 43% of 15-year-olds reported this much sleep in 2012. So again, just over half. So let's say just over half means about, let's say 51%, right? So just over half, let's just be very, very literal, 51%. So back in 91, 51%, but now only 43%. So obviously something is happening to give you guys less sleep. Now, again, it could be a lot of things, right? There's a lot of anxiety now, which could be caused by social media. There's a lot more worry, it seems like, today. So I get it. But again, put your cell phones down. A, can the results of this study be generalized to all teens in the years 91 to 2012? Explain. So when you see the word all, that means population. So the question is, can you generalize this to the population? Well, the only way is if there was a random sample, or random selection. And if we take a look here, using random sample of teens from 1991 and 2012, yes, they did do random sampling. So yes, we can generalize this to the all teens, the general all teens in the years 91 and 2012. So again, we say yes because the study used random samples of teens from 1981 and 2012. And again, the keyword is random samples. Because you had random sampling, you can generalize it to all the population. All right, B says, based on this study, Is it reasonable to say that the use of social media is the cause of the reduction in sleep? Can we talk about cause and effect? Which means, do we have random assignment? And if you look at this, there was no random assignment. This is an observational study. There were no treatment groups. We simply looked at 1991 compared to 2012. We didn't give one group something, one group. We just observed. So because there's no random assignment, no, we cannot uh, we cannot use this cause and effect relationship. So we're going to say no because the teens were not randomly assigned to use social media or not. Right? That would be the real kicker. Okay, and again, in parentheses, I put this is an observational study, not an experiment. So again, there was not randomly assigned. Okay, and again, that would be the idea, right? If you want to see if social media causes the reduction in sleep, you create two groups. You randomly assign one to use social media and then one to not use social media, and you compare their sleep, right? That's the idea. That would be an experiment. But again, this was just an observational study. And we learned way back in section 3.1 that observational studies are a terrible, terrible way to show cause and effect, only in experiments. Okay, this objective is so important that there's a second example in regards to it. Here it is. Example 2 is silence gold, and many students insist that they study better when listening to music. I think I kind of subscribe to this idea, but again, it's about what music are you studying to. Okay, so again, I think there's music that does positively influence studying. A teacher doubts this claim and suspects that listening to music hurts academic performance. Here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the semester. What conclusions can you draw from each study, assuming the mean GPA of students who listen to music while studying is significantly lower than the mean GPA of students who didn't listen to music while studying? Explain. So this is the result, right? Right? This is the result. And we want to know what conclusions. So our 2 conclusions are inference about the population and inference about cause and effect, right? That's our conclusions. Okay. And again, this is our result. So A, get all the students in your stats class to participate in a study. Ask them whether or not they study with music on and divide them into 2 groups based on their answer to this question. So do you see random sampling involved? Do you see random assignment? And frankly, I see neither. So in this example, there is no random sampling, no random sample, or random assignment. Because of this fact, we cannot make inference about the population, or we cannot make inference about cause and effect. So this is how you could write the answer. So because there's neither, you're going to say something like this. We can conclude, and this might not fit, I'm sorry. We can conclude that only the students in this stats class who listen to music while studying have lower GPAs on average, have lower GPAs on average than those who do not listen to music while studying, than those who do not. I'm going to come up here, listen to music while studying. So that's the population idea, the fact that we can't. It is just to this stats class. We would like to do it to the whole whole student body, but we can't. All right. Um, then the random assignment part and the no cause and effect. However, we cannot say, we cannot say listening to music causes the lower GPAs. The lower GPAs. Okay, sorry about that. So that's the whole cause and effect, and the fact that we cannot say, however, we cannot say listening to music causes the lower GPAs. Okay, so that's the first study, and again, that had no random assignment or random sample. So now we say select a random sample of students from your school to participate in a study. Ask them whether or not they study with music on, and divide them into two groups based on their answer to this question. So again, I do see random sample. So there is random sample here, but I still don't see random assignment, right? We ask them this question, then we divide the groups based on the question. That's not random assignment. So there is random sample, but there's no random assignment. So my answer can be very similar, except now, random sample, sorry, but no random assignment. So now it's going to be able to infer about the population, but still no cause and effect. So my answer looks like this. We can conclude that all the students at this school who listen to music while studying have lower GPAs on average than those who do not listen to music while studying. Than those who do not listen to music while studying. So that's the population idea. And again, we can say all students at this school. So that's the population. But now, we still cannot say that it causes it. So we're going to finish it with the same way we finished the last one. However, we cannot say listening to music causes the lower GPA. And there we go. Okay, so that is random sample, but no random assignment. So again, sorry, I snuck that word random sample in there. Okay, all right, next. So we have two more prompts, two more studies, same exact prompt though up here, right? So the question still is, again, or the answer still, mean GPA of students listening to music while studying is significantly lower than those who don't listen to music. So now our third study says, get all the students in your statistics class to participate in a study, randomly assign half of the students to listen to music while studying, and half to abstain or not listen to music while studying. So again, I don't see random sampling, but now I do see random assignment. So this one has random assignment, but there is no random sampling, right? So random assignment, but no random sample. Okay, so again, we cannot conclude that all students, it's just the ones in the stats class, but now we can conclude cause and effect or infer cause and effect. So my answer looks like this. We can conclude that listening to music while studying causes, right? So now we can conclude that it causes students to have lower GPAs on average. So that's the cause and effect piece because of random assignment, but only for the students in the stats class. And again, so we're not doing the whole population, just the students in the stats class. And again, that's because of no random sample from the entire population. And last but not least, our fourth example, select a random sample of students from your school to participate in a study, randomly assign half of the students to listen to music while studying and half to abstain. So now this is the gold standard. This is the random sample from the entire school and randomly assigning. This has the best of both worlds. So random sample, and random assignment. Okay, so here's our answer, very similar to the one above. We can conclude that listening to music while studying causes students to have lower GPAs. On average, for all students at the school. So again, cause and effect because of random assignment, and for all students at the school because of random sampling. So again, sorry about the longer video again, but this had two examples. It's very important, this scope of inference. So keep that in mind as you are doing these problems, because again, this is truly what we want to do. We want to make inference about the population from a sample, and when we do experiments, we want to be able to conclude cause and effect. All right, objective 2 is coming, a little bit shorter video, or very, very much shorter video.